and welcome back. This is another kinematics equation example. In this example, it's going to be a little tricky because we maybe don't have all the information we might want, so we have to sort of figure out a roundabout way to get where we need to be. So in the following scenario, there's a train, and over the course of 5 minutes, it travels 1 kilometer, 1,000 meters. We will assume that the initial velocity, we will assume that it starts from rest. So think what that means. Oh yeah, rest means initial velocity is 0. Apologize, my stylus is a little sluggish here. And we will assume that there are 2 parts. To the trip. So kind of, I don't know how long it goes, but let's go ahead and just kind of indicate sort of part 1 and part 2. For part 1, we will assume the acceleration is constant. For 1 minute. Okay, so for 1 minute it has a constant acceleration, but we don't know the actual value of the acceleration. It's just taken to be a constant value. For part 2 of the trip, we assume the acceleration is 0. So that just means that the velocity remains constant, that last portion. And just subtracting 5 minus 1 would leave 4 minutes. And the question is, what should the acceleration be in that part 1 time interval? So we want to find the acceleration during part 1. Okay, so that's our goal. So trying to find the acceleration during part 1. Let's kind of highlight, what are the things we know? We know that it starts at rest, so V initial. And I'm going to label things here. I'm going to say V initial 1 for the initial velocity for part 1 is 0. We know that the time for part 1 is 1 minute, so that'd be 60 seconds. We know that, that's about all I know about part 1. For part 2, I know the time for part 2 is, well, it's 4 minutes. 4 times 60 is 240 seconds. Very good. And the last thing I know is that the acceleration for part 2 is 0. Okay. Well, one other thing. I know that the total distance, so that would be delta x 1 plus delta x for part 2 equals 1 kilometer, 1,000 meters. Okay, so those are I think that pretty much exhausts everything that I know about this scenario. So we're trying to solve for an acceleration in that middle portion, or sorry, in part one. So a reasonable thing to try to do is to use a kinematic equation. And let's see, so I might say something like delta x for part one. I'm going to use kinematic equation 2 because I know the time for part one, so I better use the equation that involves time, equals the initial velocity for part one times the time for part one, that's just 0, plus 1/2 the acceleration for part one times the time for part one squared. So, can I solve this equation? I don't know how large of a distance the first part is, so I don't know delta x1. I also don't know the acceleration for part one. So I have two unknowns here. Well, I tell you what. What if we just go on over to part 2 of the trip? So part 2 of the trip, I could write out delta x2, and that would be the initial velocity for part 2 times the time for part 2 plus 1/2 the acceleration for part 2 times the time for part 2 squared. And this is 0 because there's no acceleration for part 2. So in the second part here, I don't know the displacement, and I don't know the initial velocity for part 2. I know that the initial velocity for the whole motion is 0, but for part 2, that really starts when it's in the middle. And so its initial velocity is certainly not going to be 0. Well, shoot. So I've got two equations, and I've got a real problem. I've got two equations right now. I've got 4 unknowns. Well, look what I have here. I haven't used this information, so I want to leverage that fact to kind of motivate what I should do next. So I don't know anything about delta x1 directly, and I don't know anything about delta x2 directly, but I do know that if I add them together, I have this extra fact. So let's try to do that. So I'm going to add these two together, and I'm going to get that 1,000 meters equals delta x1 plus delta x2. Now, if I look at this, I have an unknown acceleration. I know the times, those are given. It's 1 minute and 4 minutes. And I don't know the initial velocity for part 2. So is there a way I could figure that out? And of course there is, because the initial velocity for part 2 is nothing other than the final velocity for part 1. So I'll write that over here. Oh, I think I'll put it over here. Note, V initial for part 2 is nothing other than the final velocity for part 1, which means I can use kinematic equation 1 for that. And that would simply tell me that that is 0 plus acceleration for part 1 times the time for part 1. Using the first kinematic equation, and part 1 starts with 0 initial velocity. So that means I can replace acceleration 1 times time 1 everywhere I see v initial 2. And I can write this as 1/2 acceleration 1 time for part 1 squared plus a1 t1 T2, or rearranging, right? That is A1 times 1/2 T1 squared plus T1 T2 equals 1,000. Or let's just kind of write it all in there. The acceleration for part 1 must be 1,000 meters divided by quantity, half T1 squared plus T1 T2. And now I'm going to pause the recording just for a minute and I'll type it all in my calculator and get what I get. Okay, having typed it all in my calculator here, I find that the final answer, oh, what are you? That's what happens when you use the free one on your phone. I find the result that the acceleration for part 1 must be 0.06, sorry, slow stylus, 1, 7, keeping 3 digits, and it'd be meters per second squared. Okay, so hopefully you got those same numbers. If I made a mistake, but I don't think I did, but if I made a mistake, let me know and I'll fix it. This is a kind of a neat problem because you don't really have all the information you wanted to have. I couldn't solve for delta x1 and I couldn't solve for delta x2. It turns out though, if I put them together in just the right combination, I could solve the problem. And that was the goal. So I'll catch you next time. Bye.